So this is chapter 4, section 3, number 25. What are we doing? We're trying to graph this. We want to find as many points as we can. I think the easiest one that I like is the Y-intercept. So the Y-intercept is where it crosses this line. But this line, you'll notice X is 0 on this line. So to find the Y-intercept, you just set X equal to 0. I like that. F of 0 is 0 minus 3 times 0 to the 1/3, 0. So we know it crosses at 0, 0. So I'm going to plot that point for us. Let me erase this graph. So we know it goes through the point 0, 0. So now we already have one location that's bueno. Then we're going to keep going and we're going to say, hey, where does it cross the x-axis? Because this is all information that helps us to graph. An x-intercept, if you look, where it crosses the x-axis, but we know y is 0 on the x-axis. So for that one, we set y equal to 0, and we get 0 equals x minus 3x to the 1/3. So here's how I'm going to do this one. I'm going to rewrite this. There's a couple ways we can, but I'll just rewrite this. No, I won't. I'm a liar, liar, pet. I'm going to factor out the x to the 1/3. They both have an x. So I'm going to factor that out. Well, that I'm left with 1. Now, the question is, this plus that must equal what? Oh, whoa, 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 Yoshida. I'm having issues this morning already. That we took out, so it's gone. We don't have that. But we didn't take out all of this x, only x to the 1/3. So here's a question. This plus that must equal that. And there's a 1 there. So that's got to be a 2/3. Okay. Now we set each one of those equal to 0. Well, this one's easy, 0. I can do that. The second one, I add 3 to both sides. Now, to get rid of the 1/3 power, I cube both sides. I could do this in one step, but I'm not going to. So we end up with x squared equals 27. We square root both sides. Don't forget the plus or minus radical 27. And if you figure that out, I have a calculator. Let's do that real quickly. Radical 27. That's about 5.2. So we know it crosses the x-axis at plus or minus 5.2. That's valuable information. Excuse me. So I'm going to plot a point at 5.2. 1, 2, 3, 4, 5.2. It crosses there. 1, 2, 3, 4, 5.2 crosses there. I need to erase these because those aren't true. So I have 3 points that the graph goes through now. I'm getting somewhere. Now the rest of the graph, I need to find relative maxes, relative mins, concave up, concave down, all that good stuff. So now it's time to take derivatives. The first derivative, 1. You bring the 1/3 out in front, decrease the power by 1. And there's the first derivative. Let me do some fancy schmancy work here. Those will cancel. And we have 1 minus, and I'm going to put this on the bottom because the negative exponent moves to the bottom. But I need a common denominator. How am I going to do that? Well, the common denominator is going to be x to 2/3. So I multiply by 1, which x to 2/3 over x to 2/3 equals 1. So I haven't done anything wrong. And I get x to the 2/3 minus 1 over x to 2/3. That's my common denominator. Well, let's take the derivative again. But I am going to do the derivative in a different way. I don't want to do the quotient rule here. I want to stick with our original here. So let me rewrite this. That's 1 minus x to the negative 2/3. That is the first derivative. So I'll take the derivative of that. The derivative 1 is 0. And then I bring the negative 2/3 out in front and decrease the power by 1. And so I get 2/3x to the 5/3. Why? The 3's on the bottom. The negative moves this whole thing to the bottom. So let's deal with these. I have a first derivative that equals this. Well, what does the first derivative give us? Relative maxes, relative mins, and it also gives us something else, relative max, relative mins, and increasing, decreasing. Now you should know the only place it could change from increasing and decreasing are critical points. So what are critical points? It's where the derivative equals 0. That happens when the numerator equals 0. Add 1 to both sides. I'm going to cube both sides. And then I get x squared equals 1. Square root both sides. So I get plus or minus 1. And then where is a function or derivative undefined? Whoa, that is some bizarre stuff there. When is this undefined? When the denominator is 0. So x to the third, yeah, I can't talk. Where x is 0. So we have 3 important points. So let's go ahead and find out what's happening around those points. 0, 1, and negative 1. Why are we making this chart? Because you know only at these points can a function change from increasing to decreasing. Only at those points can you have relative max and mins. The other thing you know, this is negative infinity to infinity. Between these 2 points, it can only be increasing or decreasing, nothing else. So I want to figure out the derivative to tell me if it's increasing or decreasing. Same thing, between every set of points I have here, the function is either increasing or decreasing, so I need to figure out what's going on there. Pick some points and find out what the derivative is in each region. So let's do negative 2. Negative 2 here, I square it, that becomes positive 4. Cube root of positive 4 is bigger than 1. So 1 minus, bigger than 1 minus 1, the top will be positive, the bottom is just positive. So therefore, the derivative is positive. Plug in negative 1/2. Negative 1/2 squared is positive 1/4. Cube root of 1/4 is smaller than 1. Smaller than 1 minus 1 is negative. And you could do this on a calculator if you're not comfortable with this. The bottom, because it's squared, is going to be positive. So I'm going to have a negative in that region. Then at 1/2, same thing as, okay, understand plugging in negative 2 or 2 gets you the same answer. Why? Because if I plug in a 2 and square it, or a negative 2 and square it, it comes out the same. So because of the square on these, a positive and negative will come out exactly the same. So this will be minus and that will be plus. So what does this all tell us? We can conclude at negative 1, we have a rel max. Why? Because the derivative changed from positive to negative. At 0, we don't have a rel max or min because the derivative does not change signs. And at 1, it goes from decreasing to increasing, rel min. So we could say at 1, we have a rel min. And we can say it's increasing here, decreasing, decreasing, increasing. So increasing, decreasing, all the way through to increasing. So you can see why we have the rel max and the rel min, because the description, increasing, decreasing, increasing. We still don't have the shape of the increasing. Is it increasing like that? Is it increasing like that? I don't know. But I can plot those points because I can do that. So I want to find the function at -1 and the function at 1 and find out those values. So in the original, if I plug in 1 here and here, I'm going to get 1 minus 3, which is -2. Then I'm going to plug in 1. Oh, that was 1, huh? That was 1. Let me plug in -1. Yeah, that was, let me back up. Let's do -1. My brain. If I put -1 here and -1 here, that's going to be -1 minus -3. That's going to be +2. +2. So at -1, I'm going to have a +2. Yeah, I did have them switched. And at 1, I'm going to get a -2. Double check that. If I put a 1 here, I have 1 minus 3. That will be -2. So that makes sense. So I know I have a relative max at -1, 2. So I'm going to plot that point. Whoa, stop that. I have a rel max there. And then at +1, -2, that's going to be a rel min. It's giving me a really good picture of what this graph's going to look like. Because I see it's going through here. It looks like something like that, but I don't know for sure. We need to do the second derivative to get more information. So let's take a look at our second derivative, which I have here. Copy, let me paste it right here. And this is the second derivative. So what does the second derivative tell us? Concave up, concave down, inflection points. So where is the second derivative equals 0? Nowhere, because the numerator never equals 0. Where's the second derivative undefined? That's when the denominator equals 0. And clearly that happens when x is 0. So that's the only place where concavity could change. So I'm going to check my second derivative to the left and to the right of that point. And this is pretty easy. Plug in negative. Negative to the 5th power is negative. Cube root is still negative. So negative. And that's going to be positive, because if you put a positive there, everything's positive. What does that tell us? We have an inflection point here because the second derivative changes signs. We have concave down here and concave up here. So we know it's going to be shaped like that and like that. More information. So look, two things are happening left of 0. Increasing and concave down, decreasing and concave down to left of 0. So it's concave down and one part's increasing, one part's decreasing. So it's going to have this general shape left of 0. And that's what we see. It's going to be like that. It's concave down. So I'm going to draw that, attempt to. Okay, so it follows, it's concave down in this whole region. That's what this is saying. Left of 0 is concave down. What is this saying? It's increasing up to 2 or up to -1 and decreasing after. So it's increasing up to -1 and decreasing after. On the right side, it's symmetric. I'm just going to kind of draw it here to the best of my abilities, because it's concave up to the right of 0. And we see this is concave up. That shape's concave up. It has a relative min there, so I draw that. And it's decreasing up to 1 and increasing after. And that matches. It's decreasing up to 1 and increasing after. So that is our graph. And that's how you do